The biggest mystery in our skies just got even stranger. Harvard's leading scientist is saying it could be a nuclear-powered alien spacecraft. Something is wrong with Atlas. When our telescopes first detected this visitor from deep space, the official story was simple. It was the third interstellar comet ever detected. But the latest numbers tell a different story. Some people think this could be an alien spacecraft. Well, it's a possibility. And I've defined a scale where 0 means it's a natural object and 10 means it's a technological object that represents a potential threat to humanity. This thing is now growing to colossal size. Its coma is expanding so fast that it's on track to become one of the largest objects in our solar system. It's breaking all the rules of what a comet should be, and scientists are in shock trying to figure out what it is and what it's doing. What many overlooked in those early days was how strange its path was. It wasn't orbiting our sun like everything else. Its trajectory was a hyperbola. Imagine a cannonball that never returns to the ground, a sharp, open curve that proved it came from somewhere else, from the unimaginable depths of interstellar space. Astronomers did the calculations, and the thing nobody tells you is how rare an event like this is. Getting a glimpse of an object that has traveled for millions, perhaps billions of years from another star system is like finding a specific person in a crowd of all Earth's inhabitants. Initial estimates suggested it was a small, common object, perhaps just a few kilometers wide, the size of a small city. It was exciting, of course, but it was filed away as just another interesting data point, a third notch on our belt of interstellar discoveries. But not all things are what they seem. As observatories around the world turned their powerful eyes to Atlas, the data began to get strange. Its brightness wasn't constant. It would brighten unexpectedly, then dim again, like a lamp with faulty wiring. It was moving at incredible speed, over 100,000 miles per hour, that's 28 miles per second, fast enough to go from New York to Los Angeles in less than 2 minutes on a path that would take it flying around the sun before hurling it back into the void, never to return. Scientists settled in for what they expected to be a long, quiet observation of a frozen rock warming up as it approached our star. They thought they knew the rules. An icy body approaches the sun, ice turns to gas, and forms a beautiful, predictable tail, like steam coming from a kettle. To say the least, they were about to discover that Atlas had no intention of following the rules. The incoming data was about to reveal a shocking truth. As Atlas continued its journey toward the inner solar system, something began to happen that made astronomers straighten up and stare at their screens in disbelief. The object was getting brighter, not just a little brighter, but dramatically, shockingly brighter. In the world of astronomy, brightness is a direct measure of size and activity. When a comet heats up, ice and dust are blasted from its surface, forming a huge cloud around it called a coma. This coma is what captures sunlight and makes comets look like bright orbs in the sky, like a giant lamp in space. Typically, this is a gradual process, but with Atlas, it was an explosion in slow motion. Within weeks, its coma began expanding at an exponential rate. The numbers were so extreme that at first, scientists thought their equipment was malfunctioning. What was once estimated to be a small city-sized nucleus was now surrounded by a cloud of gas and dust that was growing to unbelievable proportions. How big? The first stunning measurement put the comet over 400,000 miles in diameter. To put that in perspective, that's more than half the size of our Sunday. It's as if a city the size of New York suddenly grew to be larger than the entire United States. You could fit the planet Jupiter, which is 11 times larger than Earth, inside this object's glowing atmosphere with room to spare. This was no longer just a comet, it was a cosmic monster. Many people are fascinated by astronomical events, but this was different. It wasn't just a beautiful light show. It was a demonstration of power on a scale that's hard to comprehend, like comparing a candle to a forest fire. The sheer volume of material being ejected from Atlas was staggering. It was losing mass at a rate thousands of times greater than a typical comet from our own solar system. Imagine a garden hose compared to Niagara Falls. The Hubble Space Telescope was quickly repositioned to take a closer look, and the images it sent back only deepened the mystery. The coma wasn't a uniform, peaceful cloud. It was a chaotic, turbulent storm of gas and dust, with jets and plumes erupting from a nucleus that remained frustratingly hidden in the glare, like trying to see the center of a fireworks explosion. The thing nobody tells you is that for a comet to produce a coma this size, it has to be incredibly rich in volatile ices that turn to gas at the slightest touch of sunlight. But even the most ice-rich comets in our solar system don't behave like this. Atlas was acting as if it were made of something completely different, something much more explosive, like the difference between regular ice and frozen dynamite. The shocking growth of its coma meant that initial estimates of the nucleus size were now completely meaningless. The actual size of the solid body at its core could be 10 or even 20 times larger than initially thought. It had to be massive to supply so much material. The scientific community was in shock, as each new measurement made the object seem less like a natural visitor and more like a celestial anomaly. This impossible growth was just the beginning of the object's strange performance. With Atlas's coma swelling to such colossal size, astronomers agreed on one thing: it was about to destroy itself. You see, this kind of explosive activity is usually a death sentence for a comet. In 2020, another comet, coincidentally also called Atlas, brightened in a similarly spectacular way. For weeks, it promised to be the celestial event of the decade. But as it approached the sun, the intense gas release acted like a series of explosions, tearing it apart from the inside out. It disintegrated into a cloud of dust and pebbles, like a balloon popping when you overfill it. A disappointing end to a promising show. Everyone expected Atlas to suffer the same fate. Telescopes around the world watched and waited for the inevitable breakup. The models were clear. An object releasing so much material so violently should be structurally unstable. It was like watching a pressure cooker trying to hold together while steam tries to escape at full force. The pressure building up inside its nucleus from vaporizing ices should have been enough to tear it apart into a million pieces, like a bomb exploding from within. Days turned into weeks, and the astronomical community held its breath. Each new image was examined for the telltale signs of fragmentation. Multiple bright spots appearing where there had been only one before, like an apple splitting into pieces. But it never happened. To the absolute shock of everyone watching, Atlas held together. It weathered the violent, self-inflicted storm and continued on its path, its monstrous coma still intact. What many overlooked was the implication of this survival. It meant that the nucleus at the heart of the storm wasn't a loose pile of ice and rubble like most comets are. It had to be incredibly dense, incredibly solid, and structurally resilient. Like the difference between a sandcastle and a reinforced concrete bunker, it was withstanding forces that should have turned it into cosmic dust. This thing was tougher than diamond. The question was no longer when it would break apart, but what in the universe was it made of? The James Webb Space Telescope was tasked with finding an answer. By analyzing light passing through the coma, Webb could detect the chemical fingerprints of the materials being ejected, like a detective analyzing evidence at a crime scene. The results sent another shockwave through the community. While it had plenty of frozen carbon dioxide, which explained some of the explosive activity, it was surprisingly low in water ice, the main ingredient of most comets. Instead, spectrographs detected unusual signatures of complex organic compounds and heavy elements that shouldn't be there. The object wasn't just a dirty snowball, the classic description of a comet. It was a complex chemical factory, and at its core was something with the strength to hold everything together against impossible odds. Then the object did something that seemed to defy the laws of physics. Comets are simple things. The sun heats one side, gas and dust fly out, and the solar wind pushes this material away from the sun, creating a tail, hair blowing in the wind. It's a rule as old as astronomy itself. The tail always points away from the Sunday always. It's like a law of nature. That's why when the first clear, long exposure photos of Atlas came back from the Hubble Space Telescope, scientists fell silent. The images were undeniable. While there was a faint, chaotic tail pointing away from the sun as expected, there was something else, something impossible. A narrow, focused beam of light was projecting from the front of the object, pointing forward along its travel path. It wasn't a tail. It was a beacon, like a car's headlight cutting through darkness? The thing nobody tells you about light in space is that it behaves in predictable ways. A beam like this, focused and directional, shouldn't exist in nature. It wasn't just a random jet of gas. The light was coherent, almost like a spotlight cutting through the darkness of space, like the difference between scattered light from a regular bulb and the laser beam of a pointer. It was such an unnatural feature that initial reports were dismissed as instrumental errors or digital artifacts. But as more observatories confirmed the discovery, a chilling realization began to set in. This was real. This is where the story jumps from a scientific mystery to something much deeper. Renowned physicist Avi Loeb, who famously suggested that Oumuamua could be an alien probe, was among the first to publicly address the shocking imagery. He argued that no known natural phenomenon could explain a focused beam of light shooting forward from a comet-like object. The energy required to generate such a beam and the mechanism to focus it was beyond anything found in nature. He proposed a mind-bending possibility. What if Atlas isn't a comet at all? What if it's a piece of advanced technology? Wild theories began to fly. Could it be a navigation beam used by an automated probe to chart its course through star systems, like a cosmic GPS? Or perhaps a communication laser sending a signal back to its point of origin, like an intergalactic telephone? Some even speculated it could be a form of propulsion, a light sail engine of a type we can only dream of, using the beam to make small adjustments to its course. The object's strange trajectory, which already showed small unexplained deviations, suddenly seemed less like a rock being pushed by gas jets and more like a craft making deliberate maneuvers, like the difference between a leaf being carried by wind and an airplane changing direction. The idea was staggering, but the visual evidence was hard to deny. A comet with headlights isn't a comet. It's something else. The most striking factor wasn't just the beam's existence, but its stability. It didn't flicker or change. It was a constant, steady stream of light pointing the way like a lighthouse that never goes out. What it did next left everyone speechless in the sun's glare. As if Atlas's bizarre story wasn't already packed with enough shocking twists and mind-bending curves, its grand finale was shaping up to be the most mysterious act of all. This cosmic enigma, an object that had defied every scientific explanation thrown at it, was now racing toward its moment of truth. It was on a collision course with its closest approach to the sun, a point in its orbit that astronomers call perihelion. Imagine a cosmic trial by fire. This is where the sun's fierce heat and crushing gravity are at their maximum intensity, like being at the center of a giant furnace. It's the ultimate stress test, a moment of maximum drama where any normal object would either survive the onslaught, disintegrate into a cloud of dust, or finally reveal its true nature. This is the moment when every telescope on Earth and every satellite in orbit should be laser focused, capturing every detail. But in a twist that seems almost scripted, we won't see anything. You heard that right. In what is either a case of monumental cosmic bad luck or perhaps perfect strategic planning, Atlas will make its closest and most critical pass by the sun while on the completely opposite side of the star from Earth. For several agonizingly long weeks, it will be totally lost in the sun's blinding glare, a period scientists call conjunction, like trying to observe something hidden behind a giant spotlight. Think about what this means. It will enter this cosmic blind spot as a massive anomaly still growing, an object that was shooting a bizarre forward-facing beam of light, and when it emerges from the other side, we'll have absolutely no idea what it has become. This period of total blindness is the ultimate suspense, like closing your eyes during the most important part of a movie, a question mark hanging over the entire solar system. What will this object do when it knows for certain that no one is watching? For the scientific community, this is a moment of supreme frustration. Decades of research and billions of dollars in technology are rendered useless, pointed blindly at a star that guards the secret. But for those who suspect this object is much more than just a rogue comet, it's a moment of supreme and chilling suspicion. What many people overlooked is that a close pass by a star isn't just a danger, it's an opportunity. It's the perfect moment for an advanced spacecraft to perform a gravitational assist maneuver. A cosmic slingshot used to fundamentally change its speed and direction without using massive amounts of fuel, like using gravity as a curve on a roller coaster to gain speed. A technologically advanced probe could use the sun's immense gravity to swing around, break its incredible interstellar velocity, or even change its trajectory and enter a stable orbit within our solar system. The fact that this critical and transformative maneuver would happen while the object is completely and totally hidden from our view is, to say the least, an unbelievable coincidence. It's almost too perfect, as if someone had planned it. Is Atlas a natural wonder, or is it a deliberate message? What do you think will emerge from the sun's glare? Let us know in the comments. And don't forget to like and subscribe.